In this video, we'll be discussing similar triangles. Triangles are given different names depending on whether we're categorizing them by side or by angle. So special names that we have for triangles when we're looking at them by side is an equilateral triangle is a triangle that has 3 equal sides. An isosceles triangle is a triangle that has 2 equal sides, and a scalene triangle is a triangle that has no equal sides. Terminology we use when referring to a triangle by angle measure. An acute triangle is a triangle that has 3 angles, all less than 90 degrees. A right triangle is a triangle that has 1 angle equaling exactly 90 degrees. And an obtuse triangle is a triangle that has 1 angle that's going to be larger than 90 degrees, and the other 2 are going to be less than 90 degrees. So 1 big angle, 2 little ones. Triangles of exactly the same shape, but not necessarily the same size, are called similar triangles. We have 2 conditions for similar triangles. First, corresponding angles must have the same measure. And second, corresponding sides must be proportional. Triangles that are both the same shape and the same size are called congruent triangles. Note that congruent implies similar, but similar does not imply congruent. Similar triangles, they have the same shape, but a different size. Congruent triangles, exactly the same. Same shape, same size. Given that triangle ABC and triangle DFE are similar, find the lengths of the unknown sides of triangle DFE. So we want to find side, I'll call this E, little e, because it's across from angle E, and I'll call this side little d, because it's across from our angle D. Now, one of our conditions for similar triangles is that their sides are proportional. We're going to solve for sides E and D by creating proportions and then solving. Now, the way you make these proportions, there's a variety of options. This is a type of problem that I know you've seen before in a pre-algebra or a beginning algebra class. So I'm going to write my proportion using left side over bottom side will be equal to left side over bottom side. That will give us the proportion 16 over 24 equals 8 over E. To solve this proportion, we'll cross multiply. That gives us 16E equals 192. And then we'll divide both sides by 16 and get side E to be equal to 12. So we'll do something similar to find our side D. I'm going to do the proportion left side over top side equals left side over top side. That gives us the proportion 16 over 32 equals 8 over D. Again, we'll cross multiply. We'll get 16D equal to 256. Dividing both sides by 16, we get side D to be equal to 16. We're again given similar triangles, ABC and triangle NMP are similar, and we want to find unknown angle measures. We're going to be using the first condition for similar triangles, that corresponding angles must have the same measure. So we can see that these two are corresponding. And these two lines at angle C and two lines at angle P tell us that they are corresponding. And then 3 lines at angle B, 3 lines at angle M. So those all have to be, the same measure. So the measure of angle C is the same as the measure of angle P, 104 degrees. Now they don't give us either M or B, but we can find M because we know that all the angles in a triangle have to add up to be 180 degrees. So the measure of our angle M is going to be equal to 31 degrees, and then B is the corresponding angle, so it'll also be 31 degrees. Our last example for similar triangles is an application. Workers must measure the height of a building flagpole. They find that at the instant when the shadow of the building is 18 meters long, the shadow of the flagpole is 27 meters long. The building is 10 meters high. We want to find the height of the flagpole. I'm going to start by drawing a diagram. We have a building that is 10 feet tall, and the shadow of that building, which is on the ground, is 18 meters long. And the building is vertical and the ground is horizontal, so it's going to create a right angle here for us. And I'm just going to make a triangle connecting those. Now I'm going to make another diagram to represent the flagpole. We've got a flagpole of unknown height, I'll call it X, that has a shadow of 27 meters. And again, we have a right angle here. And I'm going to create a triangle. Some key wording in the original problem is, they find that at the instant when the shadow of the building is 18, the shadow of the flagpole is 27. So at that instant, the sun is at the same point in the sky and has the same angled effect on both the building and the flagpole. So that means that these angles up here are going to be the same for both of them. Well, if the top two angles are the same and the bottom two angles are 90, then that's going to force the third angle in both of these triangles to be the same. And since both triangles have the same angle measures, then we know that they are similar triangles. Now that we know that they're similar triangles, we know that the lengths of their sides are proportional. So we're going to set up a proportion to find the height of our flagpole. So I'm going to do left side over bottom is equal to left side over bottom. 10 over 18 equals x over 27. As always with the proportion, we're going to cross multiply to solve. $270 equals 18x. And then we'll divide both sides by 18. We end up with x equals 15. So our flagpole has a height of 15 meters. The key thing to remember with similar triangles is that they have the same angle measures and their sides are proportional.